Learning mathematics is very, very difficult to many people, second only to learning how to speak English. Do you have difficulty? Don't be embarrassed. It's a lot of people don't know what they're doing when they get up there and do their mathematics. We're going to introduce you today to Fort Bend tutoring, honey. Personalized math tutoring is the solution.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about solving quadratic equations using the completing the square method. Alright ladies and gentlemen, at first when I was in school I used to dread this method, but now I've grown accustomed to it and it's pretty good if you know what you're doing. So first of all ladies and gentlemen, please note that the completing the square method is useful because it doesn't even matter if the quadratic equation is factorable or not. It doesn't matter. It'll still solve for your variable x. So that's why it's important. So sometimes when you can't factor a trinomial, you don't know what to do, then that's when the other popular methods, the quadratic formula and completing the square, come in handy. Alright, so let me go over the steps for you ladies and gentlemen. First of all, you always want this first coefficient to be 1. So if it's not 1 ladies and gentlemen, go ahead and divide the entire equation by the coefficient in front of the variable. The number in front of that x squared term, divide everything by it if it's not 1. But we do have 1 in this equation. Your second step is to isolate the first two terms, meaning you want to get these two terms on one side of the equation by itself. So I'm going to add 16 to both sides here. And my 16s cancel out, and I'll be bringing down this x squared minus 6x, leave a blank, and then this equals to 16, and then leave a blank as well. The next step, ladies and gentlemen, is that you'll be taking half, that's right, half of the middle term's coefficient. So I'm going to be taking half of negative 6, which is negative 3. From that point, you're going to square that value. So negative 3 squared is positive 9, so that's what we're going to be adding to the blanks that we left up here at this step. So notice on the left hand side here we now have what is called a perfect square trinomial, and you'll need to factor that, but don't fret. All you'll need to do is use the variable, and whatever this value is, in other words that half of the middle term's coefficient, that negative 3 right here, that'll always go inside of the parentheses ladies and gentlemen. So let's check it out. Let's see what it looks like. I'll have my variable x inside of parentheses, then my value of negative 3 goes inside as well, and it's going to be squared. That's right, x minus 3 squared is equivalent to x squared minus 6x plus 9, in other words that perfect square trinomial. And on the right side, ladies and gentlemen, all you have to do is just add 16 plus 9, and that gives you 25. Once we have this step, all you do from there is just simply use the square root properties. So check out our video on solving quadratic equations using the square root property, and you'll know precisely how to solve this problem. Alright, so this is what I'm about to do. I'm going to take the square root of both sides. So I'll say the square root of the quantity of x minus 3 squared equals to plus or minus the square root of 25. Then on the left side, my square root and square cancel out. I'll be bringing down x minus 3, which now equals to plus or minus 5. From there, I'll be adding 3 to both sides, because remember, we're trying to solve for x here, alright? So we got to get it by itself. So that cancels out on the left, and now I'm going to be bringing down my variable x, which equals to 3 plus or minus 5. Now, ladies and gentlemen, what does this plus or minus mean? Okay, it simply means, ladies and gentlemen, that you have two options for possible solutions, and that is the following. You'll have a solution that may be 3 plus 5, and you'll also have a solution that may be 3 minus 5. So you'll want to, of course, simplify this. And so this 3 plus 5 equals to 8, and the 3 minus 5 equals to negative 2. So 8 and negative 2 are the two values, your two solutions to the original problem, ladies and gentlemen. And I'm going to go ahead and put this in a solution set here because this is looking jacked up over here, and we don't want that. Alright, so that's supposed to be some braces over there, ladies and gentlemen. If you don't know me by now, my braces suck. So what you need to know is that the solutions are negative 2 and 8. Yep, just like that. That's completing the square, ladies and gentlemen. You follow those steps, you get the right answer, and done. Alright, let's look at some more problems. Alright, on to the next problem, which is problem number 2. In problem number 2 here, we have x squared minus 2x minus 5 equals 0. So once again, I'm looking at this first coefficient hoping that is 1 because that means I don't have an extra step. And it is 1. Fantastic. Next, you're going to go ahead and isolate the first 2 terms. That's right, get these first 2 terms by themselves. And you'll do that by adding 5 to both sides of the equal sign. That's right, that addition property of equality. Now, my 5's will cancel out, and I'll be bringing down this x squared minus 2x blank equals to 5 blank. Remember, we're placing these blanks here because we're supposed to be completing the square. And in its current state, this is not a perfect square trinomial. We're about to make it into a perfect square trinomial by doing the following. We'll be taking half of this middle term's coefficient. So I'll be taking half of negative 2. That value is negative 1, and then I'll square that value. So negative 1 times negative 1 is positive 1. And whatever I add to the left side of the equal sign, I have to add to the right side of the equal sign to keep my equation balanced. All right? From there, we're going to factor next. So remember, I told you it's going to always be your variable in whatever half of that middle term's coefficient is. So I'll be bringing down x minus 1 squared, which equals to 5 plus 1, which is 6. All right, and so that's what I have there. Now, we're going to go ahead and use the square root property. So on the left side and the right side, I'll be taking the square root of x minus 1 squared, which will always be equal to plus or minus the square root of 6. On the left side of my equal sign, ladies and gentlemen, the square root and the square will cancel out. I'll be bringing down x minus 1, and this equals to plus or minus the square root of 6. Now, you're responsible for simplifying your square roots always. However, 6 does not have a perfect square as a factor, and it itself is not a perfect square, which means I cannot simplify this. So, my next step is to add 1 to both sides of the equal sign. All right. So, I end up with x equaling to 1 plus or minus the square root of 6. And that's right, ladies and gentlemen, that's your answer. Now, some teachers and some websites, they don't have the plus or minus symbol, so they'll have you write it separately. If that's the case, then you would have to stretch it out. Let's say if it was in a solution set, you would have 1 minus the square root of 6, comma, 1 plus the square root of 6. And that's the way you would have to answer your question if that's the case. If your teacher wants you to expand the solution, meaning write it separately, or if the software you're using doesn't have a plus or minus symbol, then you would have to separate it. But fortunately for us, we're doing this digitally and you're using a pencil and paper and whatnot, so we can simply use the plus or minus symbol here. All right? Amen, amen. And on to problem number 3. So, in problem number 3, I have x squared minus 7x minus 2 equals to 0. And thus far, we had even middle term coefficients. So, it was easy to take half of it. So, some people say, well, Mr. Witt, yeah, but what happens when it's an odd number? Let's find out. First things first, we want that first coefficient on that x squared term to be 1. It is. Therefore, we move on to the next step, and that is isolating the first 2 terms. So I'm going to add 2 to both sides of my equal sign, ladies and gentlemen. Yep, my 2's cancel out. I'll be bringing down x squared minus 7x, always put a blank there, equals to 2, put another blank there, and then we'll follow the process, and that is to take half of the middle term's coefficient. So please don't make this any more difficult than it has to be, meaning don't get all fancy with decimals and stuff like that. Please don't do that. No. Instead, just multiply by 1 over 2, okay? And so you're saying to yourself, well, yeah, that might be easy for you to say, Mr. Witt, but no. It is easy. All you do is simply put the odd number over 2. So taking half of negative 7 is simply going to be negative 7 halves. That's right. I just simply put that negative 7 over 2 and done. Then I'm going to square it. So squaring this negative 7 halves, just simply square the numerator and the denominator. So 7 squared is 49. That's going to be in the numerator there. And 2 squared is 4. So I just added 49 fourths. That's it. I just squared negative 7 halves, okay? And I'm going to also do that on the right side here. So don't forget that whatever you do to the left, you got to do to the right. Keep the equation balanced. Now, you're saying, okay, well then that wasn't too bad, Mr. Witt, but now I have to factor this crazy looking trinomial. What do I do there? Remember, I said it's always the variable and whatever half of the middle term's coefficient is. So that means I'll just simply have x minus 7 halves squared inside of my parentheses. See? No stress. Then on the right side, you will need to combine that 2 plus the 49 fourths. So I'm going to show that this 2 is over 1 All right, I'm going to take my time with this process here. And I'll need a common denominator of 4. So since I had to multiply that by 4, I need to multiply the 2 by 4, and I'll end up with 8 fourths plus 49 fourths. And then when I add those two values together, I'll get 57 fourths. Just like that. From there, I'm going to be using the square root property now. So I'm going to take the square root of both sides of the equal sign here, like so. This is going to be plus or minus the square root of 57 fourths, which, by the way, is the same thing as plus or minus the square root of 57. And the square root of 4, ladies and gentlemen, is just 2, right? So I can write it that way. Plus or minus the square root of 57 over 2. All right. Then, left side of the equal sign, what happens? Yeah? The square root and the square cancel out. So I'm going to be bringing down x minus 7 halves equals to plus or minus the square root of 57, which is over 2. Then we're going to need to solve for x, right? That's the whole point of being here. So we're going to add 7 halves to both sides of the equal sign. All right. Once I have that, my 7 halves are going to cancel out. I'll be bringing down x equals to 7 halves plus or minus the square root of 57 over 2. Now, if your teacher permits, you can combine these two ratios into one fraction. So this is going to be 7 plus or minus the square root of 57 all over 2. And this, ladies and gentlemen, is my answer. Once again, if you have to expand this, you can simply write it as 7 minus the square root of 57 over 2 and 7 plus the square root of 57 over 2. But with that plus or minus symbol, it's all condensed and done. That's it. That's my value of x, ladies and gentlemen. Just like that. That's problem number 3. Okay, let's move on to the next problem here. We have problem number 4. And lo and behold, our middle terms coefficient is a fraction. But we ain't scared. So what we're going to do is the following. Our first coefficient is still 1. So we're happy there, right? So I'm going to go ahead and add 2 to both sides of the equal sign. That's right, isolating those first two terms. From there, I'll bring down the x squared minus the 3 halves x blank equals to 2 blank. Now remember, we're going to take half of the middle term's coefficient, and we're not going to be stressed about it. We're going to simply multiply 1 half times this negative 3 halves in order to find out what half of it is, right? Well, you simply multiply straight across. So a positive times a negative is a negative, and this is going to give me a negative 3/4 squared. From here, negative 3/4 times negative 3/4 is a positive 9/16. So that's what I need to add to both sides of my equal sign here, 9/16. Remember, in order to factor this newly found perfect square trinomial, you'll simply take the variable and whatever half of that middle term's coefficient was. So that means that the factored form of this is x minus 3/4 squared equals to, on the right side here, I'll need to combine these two terms together. So that means I'll have 2 over 1 plus 9/16, get a common denominator of 16, so that's now 32, because I had to multiply 1 times 16, and I had to multiply 2 times 16 to make an equivalent fraction. And then I'm going to add to that 9/16. In the numerator, I'm going to end up with 32 plus 9, which gives me 41/16. From there, we'll use the square root property, ladies and gentlemen. And that means I'll be taking the square root of the left side and the right side. You got it. You guys are doing great today, by the way. Just wanted to let you know that you're doing fantastic, and I'm proud of you. From here, my left side, my square root and my square are going to cancel out. I'll be bringing down this x minus 3/4, which equals to plus or minus the square root of 41 over, and mind you, the square root of 16 is just 4. All right, so that's how I did that. So I took the square root of the denominator 16, which is just 4, and since I couldn't break down that square root of 41 anymore, I just left it as is in the numerator. From there, I'm going to add 3/4 to both sides of the equal sign in order to solve for x, ladies and gentlemen. And that's going to give me a result that reads as follows. It's going to be x equals to 3/4 plus or minus the square root of 41 over 4. And we could combine this into 3 plus or minus the square root of 41 all over 4. And this, ladies and gentlemen, is my answer for x. All right? Just like that. That is problem number 4. All right, let's move on to the next problem here. In problem number 5, we have 3x squared minus 4x minus 3 equal to 0. And notice this time we do have a coefficient in front of our x squared term. We don't want that. So what we'll do instead is we're going to divide each and every term in our equation by that coefficient so that our first coefficient will be 1. So this rewrites into x squared minus 4/3 x minus 1 equals 0. Now that I have that first term's coefficient equal to 1, I'm going to isolate the first two terms, which means I'll be adding 1 to both sides of the equal sign. All right. From there, I'll be bringing down x squared minus 4/3 x blank equals to 1 blank. Remember, in order to find half of this middle term's coefficient, we'll simply multiply by 1/2 times negative 4/3. And now what I'll choose to do here is simplify before I multiply. So I know that 2 goes into itself once, 2 goes into 4 twice, and multiplying straight across, I'll end up with negative 2/3 that I'll need to square here. Well, negative 2/3 times negative 2/3, ladies and gentlemen, is just a positive 4/9. So I'll be adding 4/9 to both sides of the equal sign. Once I have this, remember, you only need to take your variable and whatever half of that middle term's coefficient is to factor that perfect square trinomial. So this is going to be x minus 2/3 squared is going to be equaling to, on the right side here, we'll need to add 1 plus 4/9. So I'm going to rewrite 1 as 9/9 plus 4/9, and that's going to equal to 13/9. All right, so that's what I have here. So using the square root property, I'll take the square root of x minus 2/3 squared, and this is going to be equivalent to plus or minus the square root of 13/9. Now, on the left side, the square root and the square cancel out, and I'll be bringing down this x minus 2/3, which equals to plus or minus. See, you can simplify this, ladies and gentlemen, by breaking up that square root of 13/9 into the square root of 13 over the square root of 9. It's the same step that I used on the previous problem, but I didn't show it. So I'm going to end up with the square root over, and the square root of 9 would be 3. So once I have this, my next step is to add 2/3 to both sides of the equal sign. So you know what? Let's go ahead and take this on a trip here so that we can see all of the work that's needed to do. Let's go ahead and copy that, and let's take this over here. All right, so you ready? Okay, here's a little magic for you. Bam, there's the problem. So we have this here now. I'm going to add 2/3 to both sides of my equal sign. 2/3 will cancel out. I'm bringing down my x, which equals to 2/3 plus or minus the square root of 13 over 3. And then we can combine this into 2 plus or minus the square root of 13 all over 3. And this, ladies and gentlemen, is my solution. Done and done. All right. So that was problem number 5. On to problem number 6. All right. In our last problem, number 6, we have x squared minus 8x plus 17 equals to 0. Once again, we want that first term's coefficient, that x squared term, to be 1. We want that coefficient to be 1. So it is. The next thing is to isolate the first two terms. So I'll be subtracting 17 to both sides of my equal sign here. My 17s cancel out. I'm feeling good. You're feeling good. And we're going to bring down x squared minus 8x blank equals to negative 17 blank, and then from there you're going to take half of your middle term's coefficient. So I'm taking half negative 8. That's going to give me negative 4, and then you're going to square that value, ladies and gentlemen. That's right. Negative 4 squared is negative 4 times negative 4, which is positive 16. So I'm adding 16 to both sides of my equal sign here. All right. From there, factoring this perfect square trinomial, you'll end up with x minus 4 squared, which now equals to negative 1. From here, we'll be using the square root property. So that means that I'll be taking the square root of the left and right sides. So this is x minus 4 squared equals to plus or minus the square root of negative 1. On the left side, the square root and the square cancel out. I'll bring down x minus 4. And normally, ladies and gentlemen, this square root of a negative value is an impossibility. However, we will be using complex numbers, aka imaginary numbers. And the square root of negative 1 is just I, but I'm going to show that underneath the radical here, I can change that negative 1 into I squared first. And then, let's go ahead and say the next thing we'll be looking at is x minus 4, which equals 2 plus or minus I. All right, so that's what I have there, ladies and gentlemen. Once we have that, oh, and by the way, if you want to check out complex numbers, please check out our video, ladies and gentlemen. We have one on complex numbers, imaginary and complex numbers. The link will be right down here. Okay, so solving for x, getting back to that, we'll be adding 4 to both sides of the equal sign here. And once I have this, ladies and gentlemen, you'll have x equals to 4 plus or minus I. And if you watch that video, you'll know that the real number definitely goes in front of the imaginary number, and this is our solution, ladies and gentlemen. 4 plus or minus I, done and done. Once again, ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, FBT, right there. And please go ahead and rate, comment, and subscribe. And if you're able, please donate. Peace.
We certainly hope you enjoyed today's presentation by Fort Bend Tutoring. Did you understand the program? Would you like to rate us or give us some feedback or subscribe to us? Leave a nice comment. Don't just leave something ignorant on there. If you didn't understand the lesson, ask the professor to explain it for you. Don't just get mad and write something ignorant on there.